Hi, everyone. Welcome back to the Dev Zone. So my name is Jason Scott, and I'm excited to bring to you the next presentation around leveraging cloud, data, and ML for social good. I currently am a global program manager for our startup program here at Google Cloud, and I have two special guests that are going to talk about how they're leveraging Google Cloud for social impactful work. But first, I'd like to rewind about 12 months, actually 10 months, to when Sundar announced our AI principles. For those of you who may not remember, I'll quickly go over what they were. So our first 6 principles were: be socially beneficial, avoid creating or reinforcing unfair bias, be built and tested for safety, be accountable to people, incorporate privacy design principles, and 6, uphold high standards of scientific excellence. However, today, I'd like to focus on number 7. So number 7 was be made available for uses that accord with these principles. So today, I'm going to bring up 2 of our example startups, companies, that will talk about how they've leveraged Google Cloud to, like I said, make social impactful solutions for the world. First up, I have Planet.
Hello, everyone. It's been great hearing all the tremendous announcements around AI and new tech in Google Cloud Platform over the course of the last couple of days and this week and next. And I'm excited to be telling you a little bit about what Planet's doing in the context of social good. So I'm Gopal. I head up analytics engineering at Planet. Planet's integrated aerospace and data analytics company, founded with the mission of imaging the entire world every day and making daily change visible, accessible, and actionable. Planet operates the largest constellation of Earth observation satellites in human history. And here's a quick run through of how our satellites operate. We have upwards of 130 satellites operating in a sun-synchronous polar orbit that image the Earth like a line scanner. Our flagship Dow constellation allows for broad area, always-on monitoring, and we complement that with a medium resolution constellation called the SkySat constellation that allows for higher resolution monitoring. In broad area monitoring, you're able to cover large swaths of land and be able to have precise insights derived from imagery over the course of time. So a little bit more about the Dow constellations. We image at approximately 3.9 meters ground sampling distance. We have 4 bands of imagery, and through the launches over the last several years, we now cover the entirety of the Earth's landmass every day. This allows for us to be able to image and process and serve imagery to our customers. So we have product offerings through our API that allow for access to raw and processed scenes, as well as a collection of monthly and seasonal mosaics that are available to our customers. The availability of our imagery has enabled our customers in many different verticals to provide transformative new capabilities that can serve verticals like precision agriculture, government applications, and we believe that our forward-looking vision is at the intersection of space and artificial intelligence. Very relevant to this conference. So over the last several years, our customers have been able to extract a variety of features from our imagery. This includes moving objects through object detection, land use classification through semantic segmentation, and land cover mapping using a combination of texture analysis and semantic segmentation. However, those are a few of the applications that are commercially oriented. The imagery that we produce from our satellite constellations have the potential for widespread humanitarian impact. Disasters, natural disasters, impact large swaths of population. They have the ability to affect broad aspects of our social fabric over a very quick time period. I wanted to walk through an example of cyclone area assessment. So many of you know about Cyclone Idai that impacted the east coast of Africa in March. And it had tremendous impact over large areas in the country of Mozambique. And here's just an example of like the regions which it did affect. Zooming in a little bit more closely, this is an area in the Dondo district in Mozambique that had widespread devastation. So looking at our monthly mosaics in this area, this is kind of what it looks like in January. Now, the impact of having daily imagery and monitoring through satellite Earth observation is that you're able to extract real-time information or close to real-time information of the disaster-affected areas, not just before, but also look at the catalog and history of what the area looked like. It allows you to identify spots like this with tremendous amount of human activity and human settlement. This allows disaster relief efforts to be equipped with high-precision maps of human activity, and it helps channel relief efforts in the right direction in specific locations. However, public mapping information is often incomplete. So in that particular tile of mosaic imagery, this is the existing markup of roads from a public data set like OpenStreetMap. However, when we run semantic segmentation on our imagery from a month before the cyclone hit, you're able to see a lot more roads detected. This is a differential signal of the additional roads that are detected through our imagery, and it allows for us to combine these two sources, public as well as data derived from Planet's imagery, towards creating signals that can help responders at the time of need. So I wanted to walk through a slightly more interactive example. So this is the imagery in that particular region of Mozambique. And here's an example of road detections. What you see in red are pixels classified as roads through semantic segmentation. And we can also identify other artifacts of human settlement like buildings. So this is an indicator of building footprints in that region. And you could serve this up at larger scale over multiple districts. And this is real-time information that can be used in disaster activities. Switching back. I want to talk a little bit about ocean monitoring. So typhoons and tsunamis often originate in the oceans, and they have widespread impact on land regions as well as marine life. However, monitoring oceans over large scale is like relatively complex of a problem and has been less addressed in the past. So I want to walk through an example of that. Before we look at oceans, I wanted to first look at ports. Here's an imagery of the port of Auckland taken from our satellites yesterday. And when we run an object detector, you're able to clearly identify port activity, like ships in ports, that provide a real-time signal on like the kind of aggregate activity in a region. So switching into a more interactive exploration. So this is that same region over Auckland for an aggregate activity over the entire year. So we looked at object detection over like the entire, every day over the course of this year. And this loaded up the detections in Kepler GL and open source package. And you can see real-time activity over the port over the course of time. Each of these are windowed over a couple of days, which showcase the kind of activity allowing for real-time environmental monitoring. In the same way, if you pointed to open ocean, here's an example. This is in the South China Sea, closer to the Indian Ocean, which is the origin of many, many tsunamis over the last several years. It allows you to understand real-time patterns of life, as well as activity in the marine regions that allow for preemptive signaling in the time of disasters. To switch over to a different region, which impacts all of us in terms of sea routes for distribution of material and goods, is the Panama Canal. So if you zoom in closer, we're able to detect through our imagery over the course of 2 years the kind of activity that you can see. This allows the kind of real-time monitoring that is unprecedented, primarily because of the limited coverage in open ocean as well as marine areas. So in summary, through a combination of such real-time environmental sensing as well as broad area monitoring, we're able to extract information that was previously less available. This allows us to serve transformative applications in many different vertical industries, but also serve that same information for social good, for monitoring disasters, identifying environmental impact, and understanding what's really happening on the ground at a larger scale. Most importantly, it allows us to turn our attention to problems where real-time sensing and real-time environmental monitoring can provide real value. This takes us from the realm of Earth observation imagery to derived data, and from derived data to descriptive analytics and spatiotemporal insights that allow us to understand what's happening in the world. So here are a few resources if you find this interesting. And myself and a couple of colleagues are here after the session. We would love to talk more if you're interested in insights from satellite imagery. And big thanks to Google for having us here. We use a significant amount of the storage, compute, and orchestration capabilities that Google Cloud offers towards serving up over 7 terabytes of processed imagery every day. So with that, thank you very much.
Thank you, Gopal. And lastly, in the interest of time, I'll bring right up our next startup, Mayday.ai. They can talk about, in the theme of natural disasters, how they're leveraging Google Cloud, specifically AutoML, to save a lot of lives.
Thank you.
So Mayday is an artificial intelligence-based platform, and we do natural disaster information services. So since the 80s, we have had 1.6 trillion damages. One of the most costliest years recently was 2017, when it came to flooding, storms, and wildfires, and even the red tide. 2019 had one of the wettest winters on record. Some of the biggest natural disasters that cause economic losses are storms, wildfires, and floods. About 70% of the US is at risk from natural disasters. We've shifted from being seasonable and predictable to being random and unpredictable. The frequency and severity of these storms and disasters have made management even more challenging. So a lot of the problems that we come into with disaster management is outdated platforms. They are decentralized, they don't communicate with each other. There's also a lack of education and training when it comes to these. So with Mayday, we've kind of solved some of these problems. We've created a centralized artificial intelligence platform that is cloud-based. We have microservices that track real-time and near real-time disaster information services. From those events, we have localized and group messaging based to individuals. We have a simple and user-friendly design also. We are highly affordable. We are free to students. We have $1.99 for families and 99 cents for individuals. All right, I'd like to go ahead and hand it over to Nitin, our CIO.
Thank you, Jacob. This is how Mayday.ai's ecosystem looks like. We cater to residential, commercial, and government enterprise. Our applications runs on web, iOS, and Android mobile devices. The core part of our platform is microservices in AI. Microservices being an excellent to integrate and deliver disaster information services. And AI is our brainchild. With AI, we can automate a lot of things which humans are doing. We can detect these disasters through data in real time and 24/7 and get a quick insight. Our data sources, we integrate with various data sources. We are part of NOAA's big data program. Using historical data, we train our AI based on the previous events which have happened. We also have real-time access to geostationary satellites. We get data feeds every 30 seconds for the entire continental US. We use our own proprietary algorithms to detect fire, hotspot, and other disasters. To augment our capabilities, we rely on visual inspections as well. Drone being part of one of them. Drones can go to the areas where human reach is not easily accessible. They can go and do a reconnaissance operation and give us a real-time video feeds, which we can pass it through our AI and detect actionable events. We're also planning to use drones for disaster management and control. When the fire is small, it's easy to tackle. And that's where we want to offer drones can go out and put out the fire when it's small and containable. We also want to integrate various sensors and equipments which has been installed by various climatologists and scientific organizations. Social media sentiment analysis is another piece of our offering. People who are in the disaster areas, they get the information firsthand. They tweet about it, they post videos, images, and using that social media integration, we want to analyze and bring awareness and trending of those disasters. These are some of the man-made and natural disasters which we cater through our platform. We also want to integrate through IP 911 to bring active shooter and terrorism activities in real time. This is a brief video which demonstrates the capability of our platform. Back in 2018, we detected camp and Wolseley fire within minutes of its happening. As you can see in this video, we have annotations, yellow boxes being potential fire hotspot, greens one could be false or non-event, and the red are active hotspot. We can also see smoke and cloud and other geological phenomena which helps first responders understand the situation. AI being a big part of our offering, this is a demonstration of AutoML vision. This is the first part of visual detection. We use satellite imagery, and we hand-trained this model using, this is a short example being smoke, cloud, and clear. Using AutoML vision, we trained the model, and after training, it's available as an endpoint. Using this endpoint, we integrated real-time with our live feeds of images. And so this short example how we can detect smoke, cloud with very high accuracy. Another part of our visual offering is AutoML video. We worked with Google in a beta program where we use our drone footage and trained it to detect smoke, fire, and other objects in the scene. Imagine a drone being going to a place and give us a real-time video, and we pass it through the streaming API and generate actionable event. Using this is a third part of our AI strategy. With this, I'll hand it over to Jacob to talk about our roadmap.
Yep. So in May, we are going to launch in 8 cities in Orange County, California. From there, we are going to create disaster awareness campaigns for educational institutes and high occupancy buildings. We will also be launching later in the year, and all of US and Canada with the IP 911 integration. All right, just want to say thanks to Jason and the rest of the Google team.
And I also want to thank Google technical team who I have worked closely during the beta program. They have been really helpful, and thank you.
Thank you.